Top 25 Basic Mechanical Engineer Interview Questions and Answers. Mechanical engineering interviews test a candidate's understanding of fundamental engineering principles, practical application skills, and ability to explain technical concepts clearly. Interviewers usually focus on core subjects such as mechanics, thermodynamics, materials science, fluid mechanics, and manufacturing processes. Strong preparation requires not only theoretical knowledge, but also structured communication. Providing precise, well-balanced answers demonstrates clarity and confidence. The following script includes 25 essential basic mechanical engineering interview questions with exactly 90-word answers. This structured format will help candidates prepare effectively for campus placements, fresher interviews, and entry-level mechanical engineering job opportunities. 1. What is mechanical engineering? Mechanical engineering is a broad branch of engineering that focuses on the design, analysis, manufacturing, and maintenance of mechanical systems. It applies principles of physics, mathematics, and material science to develop machines and energy systems. Mechanical engineers work on engines, turbines, manufacturing equipment, robotics, and HVAC systems. The field includes thermodynamics, fluid mechanics, mechanics of materials, and machine design. It is considered one of the oldest and most versatile engineering disciplines, offering career opportunities in automotive, aerospace, energy, construction, and industrial sectors worldwide. 2. What is the difference between stress and strain? Stress is the internal resisting force per unit area developed within a material when an external load is applied. It is measured in pascals or newtons per square meter. Strain is the deformation or change in dimension divided by the original dimension caused by applied stress. Strain has no units because it is a ratio. Stress causes strain, and their relationship in elastic materials is defined by Hooke's law. Understanding stress and strain helps engineers design components that withstand loads without failure. 3. What is Hooke's law? Hooke's law states that within the elastic limit of a material, stress is directly proportional to strain. This means that if the applied load increases, deformation increases proportionally, provided the material has not exceeded its elastic limit. Mathematically, stress equals Young's modulus multiplied by strain. Young's modulus represents the stiffness of the material. Once the elastic limit is crossed, permanent deformation occurs, and Hooke's law no longer applies. This principle is fundamental in structural analysis and mechanical component design. What is the first law of thermodynamics? The first law of thermodynamics is based on the conservation of energy principle. It states that energy cannot be created or destroyed, only converted from one form to another. For a closed system, the change in internal energy equals heat added to the system minus work done by the system. This law helps engineers analyze engines, turbines, compressors, and refrigeration systems. It provides the foundation for calculating energy balances and understanding how thermal systems operate in practical applications. 5. What is the second law of thermodynamics? The second law of thermodynamics states that heat cannot spontaneously flow from a colder body to a hotter body without external work. It introduces the concept of entropy, which measures disorder or randomness in a system. The law explains why no heat engine can be 100% efficient, because some energy is always lost as waste heat. It establishes the direction of natural processes and sets limits on energy conversion efficiency in power plants and refrigeration systems. 6. What is the difference between heat and temperature? Heat is a form of energy transfer between bodies due to a temperature difference. It is measured in joules. Temperature is a measure of the average kinetic energy of particles within a substance and is measured in Celsius, Kelvin, or Fahrenheit. Heat always flows from higher temperature to lower temperature regions. Temperature is a property of a system, while heat is energy in transit. Understanding the difference is important in thermodynamics and heat transfer analysis. 7. What is Bernoulli's principle? Bernoulli's principle states that for an incompressible and frictionless fluid, an increase in fluid velocity results in a decrease in pressure. It is derived from the conservation of energy for flowing fluids. This principle explains how airplane wings generate lift and how carburetors mix air and fuel. Engineers use Bernoulli's equation to analyze pipelines, nozzles, and pumps. It is fundamental in fluid mechanics and helps design efficient hydraulic and aerodynamic systems in various engineering applications. 8. What is the difference between laminar and turbulent flow? Laminar flow occurs when fluid moves in smooth, parallel layers with minimal mixing between them. It generally occurs at low velocities and low Reynolds numbers. Turbulent flow is characterized by irregular motion and mixing of fluid particles, usually at high velocities and high Reynolds numbers. Laminar flow has lower friction losses compared to turbulent flow. Engineers analyze flow type when designing pipes, ducts, and heat exchangers to ensure efficient performance and minimal energy losses. 9. What is Reynolds number? Reynolds number is a dimensionless parameter used to predict whether fluid flow will be laminar or turbulent. It is the ratio of inertial forces to viscous forces within a fluid. If the Reynolds number is less than approximately 2,000, flow is typically laminar. If it exceeds 4,000, flow becomes turbulent. This number helps engineers estimate pressure drop, heat transfer rates, and flow behavior in pipes and channels, making it essential in fluid system design. 10. What is the difference between brittle and ductile materials? Ductile materials can undergo significant plastic deformation before fracture, meaning they stretch considerably before breaking. Examples include mild steel and copper. Brittle materials fracture suddenly with little or no plastic deformation, such as glass or cast iron. Ductile materials absorb more energy before failure, making them safer for structural applications. Engineers choose materials based on required strength, flexibility, and safety considerations. Understanding this difference is crucial in material selection and mechanical design. 11. What is fatigue? Fatigue is the failure of a material due to repeated or cyclic loading below its ultimate tensile strength. Over time, microscopic cracks form at stress concentration points and gradually propagate until sudden fracture occurs. Fatigue failure often happens without significant visible deformation. It is common in rotating shafts, gears, aircraft wings, and bridges. Engineers analyze fatigue life using SN curves and design components to withstand cyclic stresses to ensure long-term durability and operational safety. 12. What is creep? Creep is the slow and continuous deformation of a material under constant stress over an extended period, especially at high temperatures. It is significant in components such as turbine blades, boilers, and engine parts operating under heat and pressure. Creep occurs in 3 stages: primary, secondary, and tertiary. If not considered in design, it can lead to eventual failure. Engineers evaluate creep properties when selecting materials for high-temperature applications to ensure reliability and safety. 13. What is a heat exchanger? A heat exchanger is a device designed to transfer heat between 2 fluids without mixing them. It is widely used in power plants, refrigeration systems, air conditioning units, and automotive radiators. Common types include shell and tube and plate heat exchangers. Engineers design them to maximize heat transfer efficiency while minimizing pressure drop and material cost. Proper selection depends on temperature range, pressure conditions, and type of fluids involved in the application. 14. What is the function of a governor? A governor is a device used to regulate the speed of an engine by automatically controlling fuel supply according to load changes. When load increases, speed decreases, and the governor increases fuel input. When load decreases, it reduces fuel supply. Mechanical governors operate using centrifugal force, while modern systems use electronic controls. Governors are essential in generators, turbines, and engines to maintain stable speed and prevent overspeed conditions that could damage equipment. 15. What is the difference between a pump and a compressor? A pump is used to move liquids from one place to another by increasing their pressure and flow energy. Liquids are nearly incompressible, so pumps mainly increase velocity and pressure. A compressor is used for gases and significantly increases their pressure by reducing volume. Compressors are commonly used in refrigeration, air conditioning, and pneumatic systems. Pumps are widely used in water supply and hydraulic systems. The main difference lies in the type of fluid handled. 16. What is CNC machining? CNC machining stands for Computer Numerical Control Machining. It involves automated control of machine tools using computer programs. Machines such as lathes, mills, and drilling machines operate based on coded instructions. CNC machining ensures high precision, repeatability, and reduced human error. It increases production speed and efficiency in manufacturing industries. Engineers use CNC technology to produce complex components with tight tolerances and consistent quality in automotive, aerospace, and industrial applications. 17. What is tolerance? Tolerance refers to the permissible variation allowed in the dimensions of a manufactured component. Since perfect dimensions are impossible to achieve, tolerances ensure parts fit and function properly despite small deviations. Tight tolerances improve precision but increase manufacturing cost. Engineers specify tolerances based on functional requirements, assembly conditions, and cost considerations. Proper tolerance selection ensures interchangeability, reliability, and smooth operation of mechanical systems without unnecessary production expenses. 18. What is a flywheel? A flywheel is a rotating mechanical device used to store rotational energy. It absorbs excess energy during power strokes and releases it during non-power strokes to maintain uniform speed. Flywheels are commonly used in internal combustion engines, punching machines, and power presses. By smoothing speed fluctuations, they improve efficiency and reduce vibration. The amount of energy stored depends on the flywheel's mass and rotational speed. Proper design ensures balanced operation and durability. 19. What is thermal conductivity? Thermal conductivity is a material property that indicates the ability of a substance to conduct heat. It is measured in watts per meter Kelvin. Materials like copper and aluminum have high thermal conductivity, meaning they transfer heat quickly. Materials such as wood and rubber have low thermal conductivity and act as insulators. Engineers consider this property when designing heat exchangers, insulation systems, and cooling devices to ensure efficient heat management and energy conservation. 20. What is the difference between welding and brazing? Welding is a joining process in which base metals are melted and fused together, sometimes with filler material. It produces strong, permanent joints suitable for structural applications. Brazing joins metals using a filler metal with a lower melting point without melting the base materials. Brazed joints are generally weaker than welded joints, but suitable for delicate assemblies. Welding is used in construction and heavy fabrication, while brazing is common in plumbing and electronics. 21. What is entropy? Entropy is a thermodynamic property that measures the degree of disorder or randomness in a system. According to the second law of thermodynamics, entropy of an isolated system always increases over time. It explains why energy conversions are never completely efficient and some energy is lost as waste heat. Entropy helps engineers evaluate irreversibility in thermodynamic cycles and understand limitations in engines, turbines, and refrigeration systems. 22. What is a boiler? A boiler is a closed pressure vessel used to convert water into steam by applying heat energy. It is widely used in power plants, manufacturing industries, and heating systems. Boilers operate at high temperatures and pressures and require safety valves and control systems. The generated steam is used for electricity generation, heating, or driving turbines. Proper maintenance ensures efficient performance and prevents accidents or explosions in industrial environments. 23. What is a bearing? A bearing is a machine element that supports rotating or moving parts and reduces friction between them. It allows smooth motion while carrying radial or axial loads. Common types include ball bearings and roller bearings. Bearings improve efficiency, reduce wear, and extend machine life. They are widely used in motors, gearboxes, pumps, and automobiles. Proper lubrication and maintenance are essential to prevent overheating and premature failure. 24. What is Pascal's law? Pascal's law states that pressure applied to a confined fluid is transmitted equally in all directions. This principle forms the basis of hydraulic systems. When force is applied on a small piston, it produces a larger force on a bigger piston. Hydraulic brakes, lifts, and presses operate using this law. Engineers use Pascal's principle to design efficient force multiplication systems in automotive and industrial applications. 25. What is Six Sigma? Six Sigma is a quality management methodology aimed at reducing defects and improving process efficiency. It uses statistical tools to identify variations and eliminate causes of errors. The goal is to achieve near-perfect performance with minimal defects. Six Sigma follows structured phases such as define, measure, analyze, improve, and control. It is widely used in manufacturing and service industries to enhance product quality, customer satisfaction, and operational performance. Preparing structured and precise answers to fundamental mechanical engineering questions significantly improves interview confidence and performance. Interviewers evaluate not only technical knowledge, but also clarity, logical thinking, and communication skills. Mastering core concepts such as thermodynamics, fluid mechanics, materials science, and manufacturing processes builds a strong foundation for career success. Consistent revision, practical understanding, and mock interview practice help candidates stand out in competitive environments. With disciplined preparation and confidence, mechanical engineering aspirants can secure promising opportunities in diverse industrial sectors.